In this video, we'll review the graphs of the three basic trigonometric functions, sine of theta, cosine, and tangent. The important thing is to remember how they related to the geometry of the unit circle. I've drawn that here. Here's the unit circle. Remember, there's some familiar points along the places where it hits the x and y axis. I've drawn an angle theta in standard position, and it determines a point xy along or on the unit circle. Remember that sine of theta measures the y-coordinate of that point, cosine of theta measures the x-coordinate, and tangent of theta measures the slope of the line parallel to that ray on the terminal side. What I'd like to do is plot y equal to sine of theta. What that means is on the horizontal axis I will vary my angle theta, and as a result plot the response of the y-coordinate as it moves around the unit circle. So we're going to plot y equal to sine of theta. To do that, and of course I have a little bit of hindsight, but kind of relying on the fact that this is going to repeat itself by the time that we come around the unit circle, and that we have easy access to these points that occur at 90-degree increments from each other, I'm going to divide the theta axis into equal parts, 4 equal parts, and the first one will be pi over 2, so theta equal to pi over 2. The next one I'll go up another 90 degrees, so another pi over 2, and that will give me pi. I'll have a third pi over 2, 3 pi over 2, and then we'll go all the way back around to the 360 degree mark. We'll have 2 pi when we're done. So we're just getting some landmarks, setting up our coordinate system. At the same time, also going to do cosine of theta as well. So I've just drawn the same coordinate axis, but what we're going to plot here is the response of the x-coordinate as we go around the unit circle. So let's get started. When I start with theta equal to 0 here, I'm going to plot theta equal to 0. What I want to do is think about a 0-degree angle and how it hits the unit circle, and indeed it hits it at the point 1, 0. Sine is the y-coordinate, so that means at the point where theta is equal to 0, I should plot a value of 0 for the y value on this graph here, and so I'm going to plot a point right at 0, 0. Similarly, for cosine, I need to now look at the x-coordinate of that point, so that starts high now. When theta is equal to 0, I'm going to plot up here at y equal to 1, and I've just labeled it as 1 to provide some scale on the vertical axis. Now what we'll do is we'll continue rotating in the positive direction along the unit circle, and we're going to get to the top of the unit circle where the angle is pi over 2, so I'm going to plot a point for pi over 2 for each of these graphs. The value of sine is the y-coordinate, and so when I look at the y-coordinate of this point, I get 1. That means I need to plot a point up high where the y value is 1. So I've labeled that there, giving it some perspective. Similarly for cosine, the x-coordinate on this graph, the x-coordinate is 0. So I need to plot on the vertical axis here 0 at pi over 2. We now continue around the unit circle until I get to theta equal to pi to 180 degrees. The y value is 0. That means my sine should be 0, so I'll plot that point there at 0. And my x-coordinate is -1. That means my cosine should go down towards -1, and I've plotted that and labeled -1 to give it some scale on the vertical axis. Now I'm going to come around 270 degrees, or 3 pi over 2. The y value is -1. That's the sine. Plot it. The x value is 0. That's the cosine. Plot 0 for that value. Then finally we'll come all the way around the circle 360 degrees, or 2 pi, and we're going to wind back where we started. The y value of this point is 0, so I'll plot 0 here. And the x-coordinate of the point is 1. That means I'm going to go up high to 1. And so what I've done here is just plot 5 points on the graph of sine and cosine, and we're going to trace out the familiar sinusoidal curve that you get in each of these cases. So here's sine, tracing out the curve, and here's cosine, connecting those dots. Notice how it rises, the y-coordinate on the unit circle is rising, falls, continues to fall down to -1, bottom of the circle, and comes back to where we started. Cosine, on the other hand, starts up high with a y coordinate, or with this coordinate starting at 1, and falls and rises again until it returns back at 360 degrees, or 2 pi, to the original value. As we continue plotting here, as we go around the unit circle again, we'll just see this graph repeat itself over and over in this familiar sinusoidal wave. What we're seeing here is that the graphs are periodic. They repeat themselves every 2 pi units. They are periodic with a period of 2 pi, and what that means algebraically for us, and at least in the instance of sine, if I was to add 2 pi to my angle and go one extra 360 degree around, I wouldn't have changed the value of the sine. So sine of theta plus 2 pi is just sine of theta itself. Similar equation would be true for cosine. So there we've seen the graphs of sine and cosine. They're basically the same shape. Notice that one is just shifted. If I took this point on the sine graph and shifted it to the left, I would get this point right here on the graph of cosine, and I would see the same shape by just shifting that graph of sine. Finally, let's look at the graph of the tangent function. Notice that when I take my angle to be pi over 2, we're at this point, and I'm looking at the slope of this line right here. The slope is undefined. So when theta is equal to pi over 2, I shouldn't be plotting a point, and I'm just indicating that by drawing a dashed line there as sort of a barrier to indicate that we won't plot a point. If I was to sweep my angle in the negative direction down to minus pi over 2 to the bottom of the circle, similar thing is going wrong here. The ray is vertical, the slope is undefined, and so I won't see any point plotted at theta equal to minus pi over 2. When my angle is 0, my ray is horizontal, therefore the slope is 0, and that means I start by plotting a point right here at theta equal to 0. As I go up and increase the angle towards pi over 2, the slope of the ray will increase and become arbitrarily steep. It will get steeper and steeper and steeper, so that slope will increase. In particular, when the angle is pi over 4 or 45 degrees, the slope will be 1, and then will increase, and we'll see a vertical asymptote here as we get closer and closer to pi over 2. The value of the slope is skyrocketing. Right there at 45 degrees it hits 1, and then will eventually exceed any value as it gets closer to pi over 2. A similar graph is experienced as you go down towards minus pi over 2, but the slopes of the ray now will be negative, and you'll see something similar in going down for those negative slopes. The graph of tangent, you should spend some time thinking about why this is. The graph of tangent will repeat itself on regular intervals, copy and paste this graph over and over, and if you notice here, it only takes pi units now to repeat itself, and so yes, tangent is periodic, but its period is pi, so tangent of theta plus pi is the same as tangent of theta.